As you can see on the screen, this is our R4M wireless in vivo telemetry system. Next generation electrophysiologic monitoring for unrestricted animal research and behavioral studies. Now, let's take a quick look at today's agenda. We'll cover the product overview, key advantages, technical specifications, and application cases. So, to give you a clear picture, let's start by taking a quick look at the R4M system itself. In short, R4M is a wireless, multimodal, long-lasting telemetry system that lets researchers collect high-quality physiological data from freely moving animals. It has 3 key features. First, it's ultra-lightweight and completely wireless, allowing mice to move freely with no restrictions. Second, it's multimodal. It can simultaneously record EEG, EMG, ECG, and ELFs. Third, it offers long-term tracking with extended battery life, supporting continuous, multi-day recording across multiple animals without interruption. The setup is very simple. On the hardware side, each animal has its own dedicated recorder and receiver. All recorders connect to a central data hub, which then sends the data to the PC. This design ensures zero crosstalk between different animals. On the software side, the PC control software displays real-time waveforms and synchronizes them with the animal's video frame by frame. The collected data can also be analyzed using our analysis software. It's always better to see it in action, so here are a few real photos. The first photo shows the mouse moving freely outside the cage with the recorder attached. The second photo shows the system being used together with a focused ultrasound probe. The third photo shows the complete system setup, including the data hub and PC software. Now that you've seen the system in action, let's talk about what really makes R4M stand out. Its key advantages. A major advantage of R4M is its high throughput capability. You can easily record synchronized data and video from up to 8 animals at the same time. This greatly improves research efficiency, especially for large-scale studies and drug screening. The system also supports remote access and long-term continuous recording for up to 1 week. Most importantly, it's completely wireless, no tangled cables, allowing animals to behave naturally in standard home cages. Another major advantage is its excellent cost efficiency and ultra-compact design. It uses standard, inexpensive coin batteries that can be swapped in just 1 minute. This eliminates long charging times and significantly reduces running costs. On top of that, the lightest version weighs only 1.7 grams, perfect for young mice, and it is highly durable and delivers exceptionally clean data. Now, let's take a look at the actual technical specifications and how R4M compares with other systems. The system offers 4 configurable channels with 16-bit resolution and an input range of 10 mV. Background noise is extremely low, below 1.2 VRMS, with CMR greater than 80 dB. Sampling rate is 500 Hz per channel for electrophysiologic signals and 50 Hz for 3-axis motion tracking. The standard version weighs 2.7 grams and the ultra-light version only 1.5 gram, with continuous recording time of over 120 hours and 20 hours respectively, using standard coin batteries. Data is transmitted via Bluetooth 5.0 with zero crosstalk. The data hub supports up to 8 animals per unit, with PO power supply, Wi-Fi upload, and SD card backup for up to 2,000 hours of data. The system exports data in standard EDF format, compatible with MATLAB and Python, and can be controlled via PC software or mobile app. Here's a quick comparison between R4M and traditional telemetry systems such as DSI. R4M offers clear advantages in 3 key areas. First, it provides 4 channels compared to the typical 1 or 2 channels in traditional systems. Second, it delivers a much higher sampling rate of up to 500 Hz plus actigraphy, versus the typical 0.1-200 Hz range. Third, and most importantly, R4M has an ultra-low maintenance cost. Battery swapping costs less than $1 and takes just 1 minute, while traditional sealed implants often require a factory exchange costing around $1,500. This makes R4M far more practical and cost-effective for most research laboratories. With these advantages in mind, let's take a quick look at how researchers are using R4M in real-world applications today. It all starts with excellent baseline signal quality. The R4M system delivers an extremely low noise floor, providing clean data that rivals traditional implantable devices. Most importantly, it completely eliminates cable artifacts, even during vigorous animal movement. This results in a superior signal-to-noise ratio in freely moving subjects. Let's look at the first application case: epilepsy and seizure research. Researchers perform continuous monitoring of EEG and EMG to capture spontaneous seizure activity and interictal events in chronic disease models. The key highlight is that our wireless architecture minimizes movement artifacts, ensuring high signal integrity for precise identification of seizure onset and duration during long-term studies. Let's look at the second application case: sleep and circadian research. The typical protocol involves automated sleep-wake scoring and detailed analysis of sleep architecture NEM or REM phases before, during, and after sleep deprivation experiments. The key highlight is that the complete absence of physical tethers allows animals to exhibit more natural sleep patterns and experience significantly less stress. At the same time, it provides high-quality brainwave and muscle activity data for accurate quantification of various sleep parameters. Let's look at the third application case: anesthesia depth monitoring. The protocol involves real-time EEG monitoring to track brain activity and anesthetic depth during surgical procedures. The key highlights are that the tiny wireless footprint ensures an unobstructed surgical field for the surgeon. At the same time, continuous tracking clearly reveals the different brainwave patterns corresponding to induction, maintenance, and recovery phases of anesthesia. Let's look at the fourth application case: closed-loop stimulation. The protocol involves real-time integration of neural signals to automatically trigger stimulation such as light or electrical. A moment-specific brainwave biomarkers are detected. The key highlight is that low-latency processing enables precise, state-dependent interventions, allowing researchers to study neural circuit dynamics in real time. Let's look at the fifth application case: high-throughput research. The protocol involves synchronized monitoring of large subject groups up to 8 animals at the same time to study behavioral and physiological differences across different cohorts. The key highlight is that centralized data acquisition through the data hub significantly increases experimental throughput, which is essential for drug screening and phenotyping studies. Let's look at the sixth application case: ELF-FE and neural oscillations. The protocol involves capturing local field potentials ELFs in freely behaving animals to analyze network synchrony and brain oscillations. The key highlights are that eliminating commutator noise provides pristine ELF-FE signals, and the 500 Hz sampling rate resolves critical high-frequency components such as theta and gamma waves, which are essential for studying cognitive processing. Looking at all these real-world applications, let me quickly summarize the core value that R4M brings and introduce some of the leading institutions that are already trusting our system. To wrap everything up, here's a quick executive summary of what R4M brings to your lab. Flexibility. Study animals in their natural, unrestrained state. Efficiency. Accelerate your research by recording multiple subjects simultaneously. Reliability. Deliver clean, publication-quality data with confidence. Value. Significantly lower running costs with no expensive proprietary batteries. We are proud to be trusted by many leading institutions. These include Fudan University's Huashan Hospital, Shanghai Mental Health Center, Nanjing Drum Tower Hospital, and other prestigious research institutes such as Peking University. And that brings us to the end of today's demo. For any questions, technical support, or demo requests, please reach out directly to our global strategic partner Rude. We look forward to supporting your research with R4M. Thank you again.